Question 8a. On the shape above, draw the lines of symmetry of the shape. So we're trying to draw straight lines so that if you reflected one side, it would go onto the other. Now, typically across like this, you're going to have your lines of symmetry, first of all, vertically up and down, because the shape that's here on the left-hand side will reflect onto the other side, and you'll end up with the same shape on both sides, albeit pointing in different directions. So you've got a line of symmetry down the middle, and also if you turn your head 90 degrees, you'll notice that if I cut it in half this way, then all of the shape that's on the top will reflect onto the bottom, and vice versa, the bottom will reflect onto the top. Now, a common mistake of what people would make here is they would start to draw diagonal lines, which can be points of or lines of reflection on a cross, but if you turn your head 45 degrees, what you will find is that this part of the cross, this part that sticks out here, is not as long as that part, and so any line of symmetry that's diagonal will not work because there'll be a bit of this that when you try and reflect over here doesn't match. So there are no diagonal lines that reflect here. So the only two lines of symmetry are the ones that you see that I've drawn. Part B, shade 5 more squares of the shape below so that it has rotational symmetry of order 4. So that means that if we turn it, we will see the same pattern 4 times if you turn it 360. Okay, now this one's pretty tricky because when you go ahead and turn it, you might start to shade in some random squares, and then when you turn it, it doesn't make sense. The fact that you only have 5 more as well, so it's kind of like a trial and improvement is the best way to describe it. So as far as having rotational symmetry is concerned, first thing I would do is this. I'd say, well, if it's going to look the same each time when I rotate it, well, these corners must end up having to rotate round like that. So I can start off by shading in the 2 corners here and here. If I then look at the other square that we have, this red one here, a similar thing has to happen. As I rotate it, as I'm rotating this 90 degrees each time, bearing in mind that the center of this is here, that red square is basically going to rotate to there, then it will rotate to there, then it will rotate to there, and then the last turn would go back. So that red square, I basically have to shade that in here, here, and here as well. And it just so happens, if you count the number of squares that I've shaded, 1, 2, 3, 4, 5, it makes perfect sense for that. So the squares that I've shaded there are our final answer. I'll just get rid of that red square. There we go. And lastly, on the grid, draw a quadrilateral with 1 line of symmetry and no rotational symmetry. So as far as quadrilaterals go, your options here are a square. You've got a rectangle, you've got a rhombus, a squint square, you have a parallelogram, a squint rectangle, you have a trapezium, which has 2 parallel lines, but the other 2 sides don't have to have anything at all. It could be like this. And lastly, we have a kite. So there are 2 possible ways that you could draw a quadrilateral here without have 1 line of symmetry. The only 2 shapes that it would work for is a kite, or if I took a trapezium, that's this shape here, and I made it so that these 2 sloped sides looked symmetrical on either side, like this. Either of these 2 shapes, if you draw them, will be fine. In terms of the orientation, it doesn't matter if you draw the kite like this or if you draw the kite sideways like that, as long as it has only 1 line of symmetry, as in if it's as long as it's a kite, and as long as the trapezium has 1 line of symmetry as well. Neither of these shapes have rotational symmetry, so either would be fine. So for example, I could draw my kite like this at the top. That for the bottom part, that would be an acceptable shape. And then as far as the trapezium is concerned, I could draw this as 1 slope, this is the other, and then join the top and bottom parallel sides like that. I mean, I could also draw this trapezium a lot thinner. I could do it like this. Doesn't really matter. You've got a lot of options there. But basically, as long as you draw a symmetrical trapezium, we'll call it, technically it's called an isosceles trapezium, or a kite. Those are the only two quadrilaterals that will work, because all of the other ones here either have no lines of symmetry or more than one when you draw it. Done.